There are many types of cooling towers, but there are components that are common to most towers. All towers discharge incoming water at the top of the tower. Some types use pressurized spray bars and nozzles. Others use a distribution box to disperse gravity-fed water across the tower. Most towers have some type of fill. This is material within the body of the tower that increases the heat exchange area between the water and the air. The two major classes of fill are splash fill and film fill. Splash fill can be as simple as horizontal bars across the tower, or more complex slat shapes designed to intercept falling droplets and break them up for increased surface area. Film fill consists of vertical sheets of material that provide surfaces that promote the creation of thin sheets of water on those surfaces to maximize the heat exchange area. At the bottom of the tower is a collection basin that serves not only to collect the falling water droplets in a single vessel, but also provides a storage reservoir of cooled water for the recirculating cooling loop. Most towers have drift eliminators. This is a collection of baffles that extend across the discharge area at the top of the tower to inhibit the carryover of water droplets from the tower and into the atmosphere. They operate by forcing the exiting air to change direction multiple times. The direction changes cause the droplets to impact the baffles and drop back into the tower. Cooling towers also require water makeup and blowdown lines. As water is evaporated from the recirculating loop, fresh water must be added or made up. Makeup water can be added manually or automatically by a control loop that maintains the level in the collection basin. The water in a cooling tower contains impurities. As water in the tower evaporates, the concentration of the impurities increases and can lead to problems. To control the concentration of impurities, water is periodically discharged from the catch basin through a blowdown line. This water is then replaced with relatively clean water through the makeup line. Some cooling towers are divided into sections called cells. Each cell contains all of the components of a single tower, except that it shares a common catch basin. Each cell of a tower can be operated independently. By placing a cell in service, or by shutting it down, the overall cooling tower can respond to changes in weather conditions and cooling demand. Cooling tower designs can be divided into two broad categories: natural draft towers and mechanical draft towers. The term draft refers to the flow of air through the tower. In a natural draft cooling tower, air flows through the unit naturally, without the aid of mechanical devices, as in a chimney. As the air inside the tower is heated by the incoming hot water, it becomes less dense than the air surrounding the tower. As the less dense warm air rises up through the tower, higher density, cooler outside air is drawn into the bottom of the tower. The cooler air comes into contact with the falling warm water, is heated, and the process continues. Mechanical draft cooling towers rely on one or more electric fans to create a draft within the tower. Natural draft towers have the advantage of lower operating costs, lower noise due to the lack of fans, and a long lifespan. However, they are more expensive to build, are less operationally flexible, and require a large construction footprint. Mechanical draft towers are more compact and versatile than natural draft designs. Fan speed can be controlled to match the heat load and save energy. Their disadvantage is the higher operational costs incurred by the power requirements and maintenance of the fans. There are two types of mechanical draft towers: an induced draft type and a forced draft type. In an induced draft cooling tower, a fan at the top of the tower blows air outward and creates low pressure within the tower. This causes air to flow in through the sides of the tower and up to the fan. There are two types of induced draft towers: cross-flow and counterflow. In the cross-flow type, the walls of the tower are made up of fill. Water overflows from a gravity feed system down over the fill, and air is drawn horizontally across the fill and then out the top of the tower. In a counterflow tower, the fill extends across the tower. Water is sprayed at the top of the tower. Air enters at the bottom of the tower and flows up through the fill, counter to the falling water. Cross-flow towers require less pumping energy, have lower initial cost, and are easier to maintain than counterflow towers due to their internal construction. Counterflow towers have the advantage of being more thermally efficient, so they can be more compact and have less chance of water splashing. The second type of mechanical draft cooling tower is a forced draft tower. In a forced draft tower, fans at the bottom of the tower force, or push, air into and up through the tower. Induced draft towers are more thermally efficient due to more uniform airflow and a lower chance of air recirculation. Maintenance of the induced draft tower is harder because of the elevation of the fan and motor. Forced draft towers have the advantages of lower initial cost and easier maintenance, but use more energy and are noisier at ground level due to the location of the fans.